Hey guys, Mr. Gucci here with your second help video. This is for problems numbers 13 through 18 on your homework, where I give you the name of the compound, and then you got to give me the ions involved and the formula. This is with polyatomics, guys, so let's go. So first one's first, mercury 2 hydrogen carbonate. All right, now what are the ions involved here? Mercury is Hg. The heck did I just do? Here we go. Mercury is Hg. And if it's mercury 2, well, guess what? It has a 2 plus charge, all right? It's one of those metals that we have to identify its charge. So there we go. It tells us the charge. Format, text, superscript. Cool. All right. Now, hydrogen carbonate. This is a polyatomic ion. You can tell because it's got that ate or ite ending. They usually are almost always polyatomic. So hydrogen carbonate. Let's take a look at our polyatomic list, all right? Hydrogen carbonate, hydrogen carbonate, hydrogen carbonate. Here we go. Hydrogen carbonate. HCO3 1 minus. Hell, I'm just going to copy this. Control copy. Okay. I'm going to paste it in here. All right. There we go. Hydrogen carbonate. All right. But that's a 1 minus charge. All right. So mercury has a 2 plus charge. Hydrogen carbonate has a 1 minus charge. Let's figure out the formula, okay? And I'm going to do the drag and drop here, okay? So this mercury was a 2 plus, okay? This hydrogen carbonate, a 1 minus. All right, so let me grab some of these 1 minuses. 1, 2. Okay, so we needed 1 mercury and 2 of these hydrogen carbonates. So I'm going to do that. I'm going to type in Hg for mercury, and then in parentheses, I'm going to do HCO3. That's 1 hydrogen carbonate. All right, this HCO3 is a single hydrogen carbonate, and I just want 2 of them. All right, there we go. That is the formula of mercury 2 hydrogen carbonate. All right, format, text, subscript. I just like doing a lot of copying and pasting and changing the numbers. Okay, there we go. So there it is, all right? Hg2 plus and then HCO3 1 minus. Together they make mercury 2 hydrogen carbonate. Okay, cobalt 2 oxide. Well, you know what? This one actually, neither of these are polyatomics. This is a polyatomic worksheet. So I'm going to make this peroxide. Cobalt 2 peroxide. Well, cobalt 2 is, let's do some copying and pasting here. Cobalt 2 is CO with a 2 plus charge. Now, what is peroxide? Does it have something to do with oxygen? I don't know. Let's take a look. Let's find peroxide. Peroxide. Ooh, peroxide is O2, 2 minus. I'm just going to paste that in here. Why not? Okay. Ooh, this works out. So it's CO, 2 plus, O2, 2 minus. This is 2 plus. This is 2 minus. So their charges just cancel out. You got CO, O2. This is cobalt 2 peroxide. Format, text, subscript. There we go. 1 of each. This is not 2 peroxides. This right here is a single peroxide right here, okay? What I've done in the past is like sometimes, even if there's just 1 polyatomic ion, people like to put their polyatomic ion in parentheses in order to specify that it's a polyatomic ion. They think it makes the whole process easier for them, and if that's what they think, then you know what? It does, because it's all about their perception, all right? So if you have just 1 polyatomic ion and you'd still like to put parentheses around it, I won't shame you for that, all right? If it helps you keep track of the polyatomic ions here, that's fine, okay? Next up is strontium nitrate. Now, strontium is symbol Sr, all right? What is the charge on a strontium? Sr, strontium. 2 plus. So strontium is 2 plus. Okay, great. Nitrite. What is nitrite? Well, let me pull up this polyatomic ion list. Let me find it. Nitrate is NO3 1 minus. Nitrite is NO2 1 minus. So, okay, nitrate is NO2 1 minus. All right, so what is the formula for this? Well, strontium is 2 plus. Nitrite is 1 minus. Okay, know what I'm going to do, guys? I'm going to go do a little bit of crisscrossing. Let's give that a try, okay? What number am I working on here? Number 16? No, it's 15. Strontium, nitrite. Okay, so this nitrite has a 1 minus charge. That's how many strontium atoms you're going to have. 1. This strontium has a 2 plus charge, so you're going to have 2 nitrates. Now, this is how this looks, all right? Sr, you have one of them. NO, S, NO2, that is 1 nitrite. That is just 1. This is like a bicycle. Here's your bicycle body. Here are the wheels, okay? That's 1 bicycle. We want 2 nitrites, so it's NO2 in parentheses, 2. So Sr, NO2, parentheses, 2. Okay? So it is Sr, parentheses, NO2, 2. All right, and then I got to go through and make these little 2's into subscripts, right? You got to do them subscripts, got to do them subscripts, okay? Lead 2 hydroxide, okay? Lead is Pb, and it's 2, so it's 2 plus. Ah, these are 2 plus. They're all 2 plus. That's purely coincidental. Hydroxide. What the heck is hydroxide, all right? That's a polyatomic ion. Let's take a look. Hydroxide, hydroxide. Ah, hydroxide is OH minus. OH minus. Cool. OH minus. Okay, very good. So, lead is 2 plus. Hydroxide is OH minus, okay? Well, I can see how this is going in my mind now. This hydroxide is a 1 minus charge, so that's 1 lead. This lead has a 2 plus charge, so that's going to be 2 hydroxides. Let me tell you how you write this, all right? Pb, OH in parentheses, 2. If you have more than 1 polyatomic ion, it has to go into parentheses. Common mistake that I will see. I will often see people do something like this, okay? I will see people do something like this, like, all the time, okay? In fact, I'm going to just know for a fact, this exact question is, if I do a quiz on this exact question is going to be on there, all right? People just put the 2 next to the H. That's not 2 hydroxides. That's a lead, oxygen, and 2 hydrogens. I don't want just 2 hydrogens. I want 2 of this whole thing. And so that's why you have to put it in parentheses. If you have more than 1 of a polyatomic ion, it needs parentheses. All right, let me do one more here, and then I'll call this. So, yeah, let's do one more. All right, cesium phosphate. Oh my God, these are all +2s. This was poor planning on my part. All right, this is no longer cesium phosphate. This is going to be lithium phosphate. Okay, we'll do that. Lithium is 1 plus. Lithium has a 1 plus charge on that text superscript. What the heck is phosphate? Let's go to the list. Phosphate, 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 phosphate. PO4 3 minus. Okay. Lithium is +1. Phosphate is 3 minus. Let's crisscross it. Okay, this is 17. That's too big. That's too bold. So, this lithium has a 1 plus charge. That's how many phosphates we are going to have. Okay? This phosphate has a 3 minus charge. That's how many lithiums we are going to have. We will have 3 lithiums and 1 phosphate. This is not the answer. A phosphate is PO4. You have 1 phosphate. This is what 1 phosphate looks like. It is not just PO. That is wrong. All right, it is not just PO. You have to have a single PO4. Again, if putting this in parentheses helps to remind you that this is like a sacred bond right here, and this PO4 is not changing, do what you got to do. All right, do what you got to do. This is 3 lithiums and a single phosphate. Li3PO4. All right, this is Li3PO4. This is the formula of lithium phosphate. All right, let's paste in some of these numbers here. Li3PO4. Great. Okay, cool, guys. That was this video. I hope you found it helpful. Again, if when you crisscross to make this ionic compound, if you end up with more than one of a polyatomic ion, you gotta put it in parentheses. Parentheses are your friends here. Hell, if you want to put parentheses around a single polyatomic ion, again, if you wanted to just do like, parentheses around this PO4 on both sides to help keep straight in your mind that this is what a single phosphate looks like, then you know what? You could do worse, all right? Hooray, okay? Hooray, all right? Yeah, worse could be doing this wrong, all right? That's worse, okay? Do what you got to do. I wish you luck. On to my last video.